Alright, so this is my first attempt at a video, so please forgive me if it doesn't go very well. What we're studying today is density. It's out of chapter 5, section 3, part C. It's on page 157. Okay, so what is density exactly? A lot of students still confuse density with mass or volume. And I want to talk just again, I've done this in class once, but what's the difference? So mass is how much stuff, how much matter is there. A-T-T-E-R. Volume is how much space something takes up. And density relates the two. It's how much mass is there in a given volume. So for a certain amount of stuff, how much space does that certain amount of stuff take up? Okay, so I want to try to illustrate these differences a little bit. So mass is typically measured with a triple beam balance, something like this. That's how we're going to do it in class. You can also use a digital one. Your bathroom scale at home is attempting to measure your mass. All right, mass is measured with a balance. Okay, so how do we measure volume? Volume, remember, is the amount of space that something takes up. Well, it depends. So if it's a liquid, we can use something like that. Oh, I'm very sorry. If it's a liquid, we can use something like this, graduated cylinder. So here's the graduated cylinder, or what you probably use at home, some kind of measuring cup. All right. And for solids, we can either drop them into a graduated cylinder and measure the volume change, or we can use any of a number of formulas to determine how much space something is taking up. So the volume of a sphere here is pi times the diameter cubed over 6. Volume of a cube is probably easier. It's just the length here times the length here times the length here. It's a special case of this other rectangular prism, which is just one side times the other side times the third side. All right, as long as you measure all three sides and multiply them together, you got it. If they're all the same, then you can cube it. If they're not all the same, just multiply side A times side B times side C. And then for cylinders, down here, the volume is pi times the diameter squared. There's the diameter squared times the height, and then divide that by 4. All right? You should have some idea about that. You should be close to getting these. I think these cube and the rectangular prism are the easiest. You should probably just go ahead and memorize those, although yeah, really you should. Okay, so what do we do with this? How do we measure density? Sorry, is the question. So density is the mass divided by volume. You have to measure those separately, and there's no direct way to measure density just by itself. But the cool thing is that density is a property of a material. As long as it's a pure substance, the density shouldn't change in that substance, regardless of the mass or the volume, because one will change with the other. So table 5.8 in your textbook lists the densities of lots of common things. So gas densities are really, really low, right? For instance, oxygen gas density is 0.00133, and that would be in units grams, mass unit, divided by centimeters cubed, which is a volume unit. Hydrogen gas is even less. I'm not going to go through all of them. Here's a solid aluminum, and so we're used to seeing something like 2.70 grams per centimeter cubed. Every centimeter cubed of aluminum has a mass of 2.7 grams. Iron, when you think of iron, you think of it as heavy, right? The same size piece of iron will weigh a lot more than the same size piece of aluminum. Iron has a density of 7.87 grams per centimeter cubed. It's a lot more dense than aluminum. Okay, let's pause for a quick check here. Which has the greater density, box A or box B? Which has the greater density? Box A or B? Hopefully you all realize it's box A. There's more stuff in the same size box. Okay, so we can determine an unknown density just by taking the mass and the volume here. So the density is the mass divided by the volume. So if you have a substance, you take the mass of it, using a balance like this, or a triple beam balance, and you take the volume. So for an irregular substance, the easiest way is to take and drop it into a known volume of a liquid and then measure this change. The change in the volume is the volume of the thing that you dropped in. Archimedes discovered that. And so then you've got a mass and a volume, and you can calculate density. This symbol, by the way, I usually write it like this. When we type it out, usually we'll just say density, mass over volume, because this other symbol is hard to find on the keyboard. So density, mass, volume. Here's determination of an unknown density. But what if you know the density? What else can you find out about that material? How can you rearrange this equation to find out more? Right? So, what if you know the density? You're given a block of steel, so a block of iron. So the block of iron has a known density, 7.87 grams per centimeters cubed, and let's say you know the mass of it. Let's say it is 15 grams on your scale. So what's the volume? You can figure that out, right? Rearrange density. Must be equal to mass divided by density. So that's going to be the mass, 15 grams, divided by the density, 7.87, grams per centimeter cubed. So the volume then would be equal to, math that up, 1.9059, sorry, not scientific notation, that's it. And the units are going to be grams over grams per centimeter cubed. So units are grams over grams per centimeter cubed. And simplify that. Right, this as centimeters cubed going over the fraction. So tomorrow we're going to play with a lab where you are going to be asked to use